Okay, so today we shall get started with NumPy. Now, before we start with NumPy, we have to verify whether NumPy is installed in our machines. So it's a module which, if it is not installed, we need to install to make use of that particular module. So what I'm going to do is I'm going to go to command prompt and I'll first of all type pip. So we are going to use pip to do the installation of NumPy. So if you hit pip and enter, you will see some output. That means pip is successfully installed or already installed on your machine. So can you please try this? Just go to a command prompt and type pip and enter. You should see some output. So if you successfully get that output, then what you need to do is we will install NumPy using pip. But first of all, let us understand what is pip. So in Python, we use pip, which stands for Python Package Index, to install and manage different packages or libraries that are available. Okay. Now it is important to note that pip itself is a package and is used to install other packages, right? So basically, we are going to use pip to do installation of other packages in our machines. So I will go back to again my command prompt, and first of all I'll type cls. That will clear the screen, and here I'll type pip show and I'll say numpy. Now pip show numpy, what it does is it shows whether this particular module is installed or this package is installed on your machine or not. So if I hit enter here, it will show me that it is already installed and the version is this particular version. Okay, so can you please execute this command and try and tell me what is the output you are getting? Okay, for some of you, if you are not getting any output soon after the execution of this command, that means it is not installed on your machine. So in that case, what you can do is you can say pip install numpy and hit enter. That will go ahead and do the installation of NumPy package for your machine. So please execute this command. So once you have done this installation successfully, it's already done on my machine, so I'm not going to do it again. After that, if you say pip show numpy, it will show you the version of numpy that is got installed, and you will see the location also where it is installed and the license and few other details which you can look here, right? And as you can see that as a part of this course, we are also going to cover pandas, and this particular numpy is required by other packages as well. Can you see here? Okay, so this is the installation process using pip. Okay, so let's get started with NumPy discussion. So NumPy is a linear algebra library for Python. Okay, the reason it is so important for data science with Python is that almost all libraries in PyData ecosystem rely on NumPy as one of the main building blocks. So as you can see, most of the data related operations which you are going to perform is all reliant on NumPy, right? So it's a linear algebra library. What is a linear algebra? Let's just briefly look at what is linear algebra. So as you can see here in this screen, I googled what is linear algebra. So Wikipedia says linear algebra is the branch of mathematics concerning linear equations such as linear functions, such as the 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 date the data which is represented in matrices and vector spaces, right? Or you can say there are vectors, there are matrices, there are these transformations of this particular vectors and matrices, right? So this is the branch of or rather this is what this linear algebra is about, and we had studied in our maybe college days working on matrices, working on vectors, right? Performing transformations on them, performing addition, subtraction. So similarly, with the help of NumPy, is a linear algebra library for Python, meaning that if you have a data in form of vectors, arrays, matrices, you can perform various operations on that with the help of linear algebra, right? Now NumPy is incredibly fast as it has binding to C libraries. Now I don't know if you people know, but C is one of the most fastest programming language, or rather it is fastest programming language, and this NumPy package which we are making use of has binding with C libraries, and therefore it is very fast. Now NumPy arrays are the main way we will use NumPy throughout the course. We will see what is a NumPy array, right? And then NumPy arrays essentially come in two flavors. Vectors is a single dimensional array, right? which has a direction basically, and matrices is a matrix which could be n to n dimension, where n could be any number of rows and n could be any number of columns, right? So we can call it n by m also if you want to. Now vectors are strictly 1D array and matrices are 2D array, but you should note a matrix can still have one row and one column as well, right? So that's so the intention or the idea of using basically NumPy is to be able to work on a data which can be represented in vectors or which can be represented in matrix, right? Now why do you think it is useful? It is useful because if you will think about it, almost a huge amount of data resides in this format, whether you are looking at Excel sheet, whether you are looking at tables, right? So we have a lot of data which is stored in a matrix form, and this NumPy package gives you an ability to work on that data, process that data, and do various operations on that data. Okay, so let's look at how we can make use of that. So as a part of this discussion, we'll try a couple of things. Now, if you want, generally, we can as well go to the documentation of NumPy. So let's quickly go to the official documentation of NumPy. So you can Google and find this link if you want to. I can mail this link to you as well. So if you will go to this particular website, I'll just read through a few of this. Okay, so I'll start from here, the basics. So NumPy's main object is homogeneous multidimensional array, right? It is a table of elements, usually numbers. Maybe if you want to call it numbers, you can have other data type as well, but usually it is numbers, all of same type, indexed by a tuple of positive integers. Now, for example, the coordinates of point in 3D space 1 to 1 has one axis. One axis is, this is one row. That axis has three elements in it. Okay, so we say it has length of 3, right? In the example pictured below, the array has two axes. So one is this, right? It has two axes. The first axis has a length of 2. There are two rows, and second axis has length of 3, the number of columns, right? Now NumPy array class is called ND array. What does it mean? That if you create a NumPy array and display the type, it will be ND array. It is also known by alias array. Okay, so we are going to look at it very soon. So there are a lot of functions available here to play around with it. We will look at number of examples shown here, or rather we'll even look at more of examples. So we'll look at how to create a NumPy array, how to create a use R range, how to create zeros matrix or an array, how to create ones matrix, how to use line space I. So these are various functions that are available in NumPy. We shall play around with it and we'll try to create different types of NumPy arrays. Fine. So let's get started. So I launch my uh, PyCharm and let's get started with the programming. Okay, so here is my PyCharm. This code I have already checked in Bitbucket, and I have already shared the credentials with you. So you can feel free to make use of the code. I have in fact written code for all of them, all the topics that we are going to discuss. But anyway, we'll try here as well. So what we are going to do is we are going to create a NumPy array. So let me do one thing. Let me bring up the documentation as well so that you guys become comfortable with using NumPy documentation. So I'll start this with creating a simple array, right? So I hope you people will remember that we used to declare an array and then we'll convert that array into a NumPy array. So how we are going to do it is, let me go here and I will create a new file here, new Python file. I'll say 01 np hyphen array. Okay, so let's create an array here, arr equal to 10, 20, 30, 40, and I'll put here 50, right? Now what I need to do is I want to convert this array into a NumPy array. So in order to use NumPy, first of all I have to import that. So I have to say import and so it will show in the autocomplete, choose this NumPy as NP, right? Now what I'm going to do is, first of all, let me try to display this particular array, or rather I'll display print of maybe ARR. Let me put, I'll put ARR here. Okay, so this is displaying the array, and I'm also displaying the type of that. So first let me display this one before I go ahead and try try converting this into a NumPy array. So let me go ahead and run this. So I'm going to run this and let's see the output. So here I get a list, right? Now let me try to convert it into what you say, array. So what I can do is I can say np underscore arr equal to, I'll say np dot numpy dot array, okay, and in that I'm going to pass this arr that I have created. I'm using an np underscore arr so that I can understand this is a numpy array, right? And after that let me print it. So I'll go ahead and print this value, okay, and then I'll also display the type of this particular numpy array which I have created, right? So I will copy this also and I will put it here, right? So if I right click and run this, let's see what is the output I get. So here you will see that NP array is represented. There is a slight difference. Can you see here? Here we have with comma. Here we have them without comma. And if I display that type now, it shows as numpy.nd array, right? So this is how we go ahead and create a single dimensional NumPy array, right? And it is an n dimensional array. Can you please try this program quickly? So maybe if some of you are facing problem with that it cannot find or import this model, what you can do is you can go to settings, files. So in the editor, go to file, go to settings, and here type interpreter, INTER. Okay, if you go here, it will give you an option here on the right side. Can you see the plus sign? Click on plus and you can type here numpy, NUMPY, and then install package you can take. Okay, and once the installation is done, you can then successfully use that particular package. Okay, so please try it out. Okay, so I hope all of you have got your program running now with that installation of NumPy. Okay, so like you have created single dimensional array, can you also try to create one two-dimensional array and then display the output of this program? This is single dimensional. How we create two-dimensional? I'll copy and paste this, and I will say a, for example, I'll call it 2D underscore 2D and open bracket, sorry, bracket, comma 10, maybe 100, 200, 300, 400 and 500, right? And then try to convert it into a NumPy array and tell me the output. So if you have successfully done this program, this is how it will look like. I mean, there is not much change, so I'm not typing the whole code. So I've created a 2D array like this, and then I'm just converting np dot array of 2D like I did for 1D, and then I'm displaying the value. And if I display the type, it is again nd array, right? N dimensional array. So if I run this program, this is what I had asked you to try out, right? So it's a very simple program. Now next item that we are going to look at, or next thing we are going to discuss about is np.arange. So this is a method which is available in NumPy. I am going to mail one documentation to you. So if you want, you can open that documentation on your machines locally. So I'm referring to this documentation. This is an official site of NumPy. Okay, so if you will come here in the documentation, if you will search for arrange here, if you will open this particular page on a new browser, it will show that it what does this function do. It returns an evenly spaced value with a given interval, right? So here you have an option to give start and stop and step. So let me explain to you how it works. So let me go ahead and bring up my PyCharm. Okay, so I'll say so as I need to use NumPy, first of all I have to import NumPy as NP. Then I'll say NP dot range, right? RANGE. Initially, I'll just give a number 5 here, for example, and I'll say NP1, right? And after doing that, let me go ahead and print this value. So I'll say NP1, and I will copy and put it like this. So let's see what is the value. Right click, run as. So I have got 5 evenly spaced values. Yes. Now again, if I go back to the documentation, let's see, it is returning evenly spaced values within a given interval. So from since I said 5, I need 5 values. So it starts from 0 up till 4, which are evenly spaced by 1 to 4, by evenly spaced by 1, right? Now another option I have is that I can choose start of a numpy and end of a numpy, right? So as you can see from this documentation, it has a start as well as end, right? When I mean end, I mean the stop here, right? So let's try to create another numpy. So I'll say np2 equal to np dot arange. Okay, here I'll give 0 to 10 maybe, and then I'll say print of np2, right? After that I'll say, right? So I'll right click and run this program, and let's see, I'm getting evenly spaced values from 0 to 9. Another option which is available for me is I can create np3, for example, 3, and I can also specify step here. So if I give here 2, it says step. What is step doing? Spacing between values, right? So, and here I'll say np3 and np3, right? So let's try to run this program. So this time you will see evenly spaced values with a step of 2, right? So this is how we can use our range function to create a NumPy array, right? Can you please try it out? Okay, so next one is we'll see how we make use of zeros. So again, I will go back to my documentation. Let me close this one, arrange, and let me search for zeros here. ZERO. So can you see here are zeros? So I will open this. So these are various methods that are available in NumPy to use, right? So in the zeros, I can define a shape and I can give data type, D type here, right? So let me create zeros NumPy array. So I'll open zeros here. So I'll say np dot zeros, right? And I'll, for the timing, I'll give a value of 5 here, and let me see what I get. np1 equal to this, and I'll say print of np1, and I'll also display the value for that, right? So let's go ahead and display, right click, run as. So I get the value as 0 dot 0 dot, all are floating point numbers, right? Now let me also say print of np of 1, and I'll say, let's say, 1th element, right? So if I right click and run as, I'll get that particular element. Yes. So what if I try to display the type of this? So if I display the type here, what will I get to see? Let's see. This is a floating point number, right? So what happens is that when you are creating the NumPy array using zeros method, it by default creates a float 64 number, but you have an option to specify d type also, right? So if I go ahead and say that, let me change this to comma d type equal to I and t, for example. If I do this, then let's see what happens. Right click, run as. I'm getting all integer zeros now, right? Similarly, here I have given a single number 5. What if I give a two-dimensional tuple? So let's do that. So I will copy, and maybe I'll save time. I'll copy and paste it, and I'll make it np2 here, and I'll make it in the bracket. I'll make 5 rows and 5 columns, and data type, if I leave it default, it will be float, right? But I'm leaving it as int here, and I'm displaying np2. So I'll make it np2 here, and I'll also make it np2. So this time it is going to create a matrix for me, zeros matrix, which is 5 rows 5 columns, and I can display the entire matrix. And when I display one of the value from that, okay, so this will be np2 will be the 0th first row. If I want to access an element, I have to say 1 1, right? Yes, no. So if I right click and run this program, so this is how I, so basically, first of all, let me also display the value, and then I'll display the type. So I'll remove the type from here for the time being, and I will remove this as well, and let me run this. So as you can see, np2 is this particular 5 by 5, right? And it is integer zeros because I have specified the d type as int here, isn't it? Now I display that np. Now if I run this again, so you will see that the value 0 I get here, and integer 32. And what if I remove this? If I run this, right click, run as, here I get float 64, right? So can you please try this program? Okay, so like we have zeros, there is a method called ones also. I'm not going to spend time typing this code, and maybe you can also try it. I already have the code working for you. I'll just show to you. So like zeros, this is ones. So it will create a NumPy array of ones, right? So if I run it, so you will see it is 1 decimal here, right? Why? Because by default it creates a float data type. If you want to specify d type here, it will create in d type, right? And this is a two-dimensional array, 2 rows 3 columns, right? So this is 2 rows, right, and 3 columns. Fine. So this is something maybe you can try it out by yourself, or maybe I can change a d type at least here. So I'll say d type equal to int, for example. So if I run this program, I'll start getting integer data type in the array here, right? So a lot of, or in fact all this information you can search from documentation most of the time. So just 1 minute. So if you will go here and search once, can you see this here once? So uh, I'll do one thing. Let me mail this link to you. Can you all open up this on your machines or on your desktops so that we can keep referring to this particular link? Okay, so if you'll open this link here, there is a method here. So let me open this. We are going to talk about line space now. In the line space, what you can do is you can let the page load. So in the line space, what you can do is you can define a starting point and end point and define number of equi-spaced spaces or equi-spaced points that you want out of that function. So what I mean by that is, let me uh, open up my PyCharm and let's try it out. So let me delete this. So I'll say np dot line space start from 0 up till 5 and I want 5 values, right? So let me just see if it is up here now. Here, so it's start and stop. So it returns evenly spaced numbers over a specified interval from 0 to 5. How many points I want, or evenly spaced numbers I want 5 of them. So starting, ending, and how many I want, right? So let's say np1 I'll call it, and let's try to display that. Print of n np1. Okay, and then right click, run as. So can you see they are equally spaced, 0.25, 0.25, 0.25, right? So that is how we make use of. What if I make here, let's say I make here 50. So I'll make 2 instead of, uh, let's take a maybe 20, a bigger number, 20 equally spaced numbers in between 0 and 5. So I'll make it 2 here and I'll make it 2 here. So let's right click and run this. So can you see this result here? Yes, can you please try it out? Okay, so I is something like where something wherein you can create a matrix with the diagonal being 1 here, right? So here I am creating a matrix with a diagonal as 1 1 1 1, as you can see here, right? Now next is shape or reshape. How we make use of shape or a reshape is that, let me create a copy of this one. Okay, so let's try this. So I'm okay, I'll keep this much. I'm converting this into NumPy. Okay, this much we have already seen, so I'll not type this whole code again. So I've created a one-dimensional array here and I convert it into NumPy and I display it, right? So here I get the output as a NumPy array. Now let me also try to display the shape of this particular array. So I will say dot shape. Okay, let me copy this and put it here. Right now, if I see the shape of this one, the shape is 6 comma 6 comma means it's a single dimensional array, right? Now what I'm going to do is I'm going to take this NumPy dot reshape to how many elements are there? 6 are there. I'll say 2 comma 3, right? So it will be 2 rows and 3 columns, right? So I will say np 2 3 equal to this, and then I'll print the value, print of np23, right? So let's see what is the value of that one, equal to comma run. So can you see it is showing up as a matrix now, and the data has been reshaped in the form of 2 by 3 matrix. And if I try to display the shape of that, so if I go here and say print dot shape, dot shape, right? So let's see what is the output of this going to be, dot this. So if I try to run this program, so it shows 2 rows and 3 columns here, right? Can you please try it? Okay, so some of the functions which I have asked you people to try by yourself, I believe you would have done it. So one of them was reshaping, we just did. Then min max was to find the maximum and minimum from a given array. And with the arg max, you can find the argument of that particular maximum value in the n dimension and that NumPy array, right? Then D type, data type, we have already seen that suppose you create an array, you convert it into NumPy array, and you can say type to display the type of that particular. Uh, so this is NP D type. So suppose I have an array 1D here, I convert it into NumPy, and then I can display the data type of that particular array, right? A little while earlier we had seen that you can as well specify the data type that you want to choose when you are creating a particular NumPy array, right? Now next is selection. So this is something which we have already done quite often, but we'll just try out few more examples here. So I will go to this file. Now let me delete all this. Let me keep this, and I will, this is my NumPy array, right? Now we have seen slicing already, how we work on slicing, right? So if I say print of uh, this particular array, if I take and if I give here 1, or let's say 2 we give here. So if I run this particular program, first of all it will give me the value of this array from range 0 to 11, right? So run this, so it is giving a value excluding 11, right? And if I say 0, so 0th value, first value and second value, so that's why it gives me this one, right? Second is, if I want to do slicing, how can I do it? If I say colon 5, what it will give, starting from 0 to 5, so which is actually 0 1 2 3 4, colon 5 means excluding 5, right? If I run this program and if I say 2 colon starting from 2 up till the end, right? So I run this from 2 up till the end is included here, right? Similarly, if I give here 2 colon 5, so if I run, sorry, if I run this, if I run this program, so I get 2 3 4, starting from 2 and 3 and then 4 excluding the fifth one, right? So this is slicing how we have done. Can you quickly try 2 3 of this combination before I can move on to the next item? Okay, so this one is a pretty simple one. We have done slicing a number of times, so we'll not spend a lot of time on this one. So instead, what we look at, how we can do slicing of two-dimensional array. In fact, we have seen that as well, but there is a slight change in this, what you say, in NumPy. So I'll just talk about the change. Rest of the things uh, I will delete this. Let me delete this. I'm not typing the whole code because I have been doing it every time. So this is a two-dimensional array. We have created this multiple times. So 1 row, 2 row, 3 row with the columns, right? I convert that into NumPy array and say NP two-dimensional array, right? So this is something we know how it works, right? Now what I'm going to do is I can display the type. So if I run this, it will display me the value of this array as a two-dimensional NumPy array and the type of the array, right? Which is ND, right? So let's quickly run this program. So this is the original array, right? Which is a 3 rows and 5 columns. This is in a NumPy array, and data type is class NumPy.nd array. This is the type of the this particular type of the array. Now, if you want to access the element, you can say print of where is that this is the right. So if you use single bracket notation, we know if it's a two-dimensional array, we can say, for example, two second row and second column, right? So second row means this is first row, sorry, this is zeroth row, first row, second row. So this is second row, second column 0 1 2. So I'll get output as 300, right? So right click, run as, so I get output at 300. This is when I'm making use of double bracket, right? Same thing I can try to do it with this particular uh, say 2 comma 2. This is a little bit more readable and more convenient to do, right? So I can say right click, run this, I get the same value, right? So this is called single bracket notation. Can you please quickly try this? So if you want, I can mail this file to you. You just make changes in the last 2 lines here. Don't type the whole code. There is no point in typing this whole thing. I'll mail it to you. Okay, so next thing that we are going to talk about is broadcasting. What is a broadcasting in NumPy? So this is the official website from where we will understand broadcasting. So as you can see here, the term broadcasting describes how NumPy treats array with different shapes during arithmetic operations. Subject to certain constraints, the smaller array is broadcast across the larger array so that they have compatible shapes. Okay, so let's try to understand this with an example in some time. Broadcasting provides a means of vectorizing array operations so that looping occurs in C instead of Python. So let's just look at a simple example here. So let me bring up my PyCharm. Uh, okay, so okay, so this is a piece of code which I have, and this is I've just created it with the arrange method which is in NumPy, right? Now what I'm going to do is I'm going to do a broadcasting in this. I'll say np underscore arr, and I'll say open bracket close bracket from 0 to let's say 4 here equals to 100, right? Now before I do that, let me display the value of np underscore arr. So I'll right click and run as. So I get a value from 0 to 10, right? Now after that I am doing broadcasting on this array from 0 to 4, and after that I try to display the value again of this NP on this particular uh, uh, let me run this again. Here you will see that that value I had assigned from 0 to 4 had got broadcasted on the original array or original NumPy array which I had created. So this is a concept of broadcasting. Now what you can also do is, let's say this is one way of broadcasting. Another way is, let's say I create a slice slice I s l I c e of slice array equal to, let's say I have uh, let me create another one here. I'll make it 2. Okay, so I'll create a 2 here, and then I slice this one from 0 to, let's say 5. Okay, now before I slice that, let me also try to display the value of this print of np equal to comma of this, right? Now I'm slicing. So if I slice it, what will happen? If I print the slice, I will only get that much part. Is that right? So I'm going to say, I'll say comma and right. So this slice will only display me value from 0 to 5. So let's first run this. So here it is 0 to 10 and slice is 0 to 4. Now what I'm going to do is I'm going to broadcast on this slice. So I'll say slice, I will take this and I will slice. If I put colon, it is starting from beginning of the slice till the end, and I'll put here 500, right, or 5000, whatever you want to. And now if I go ahead and try to print the original array which was here, so let me display this again. Right click and run as. Can you see that those values are again broadcasted on the original NumPy array which we have created, right? So this is a concept of broadcasting in Python. So basically you are working on a slice of the original array, and with that you can broadcast values on the original array, or rather you are working on the original array itself rather than having to create multiple values of the original NumPy array. Fine. So can you try this? Okay, so next thing which we look at is how we can perform various comparisons. So let me close all these files. Okay, I'll create a copy of this one. Okay, so let me delete all this from here. Okay, so I will say that NumPy, let's say it creates a NumPy array for me from 0 to 10. So I'll say greater than, for example, 5. Okay, so CUMPARISON underscore comparison underscore ARRAY, right? So this is my comparison array. If I try to print this value, let's see what happens. Print of this one here, right, equal to comma of this. So if I try to run this, right click run as, what happens? I get the values false for which it is not greater than 5, but for the values where it is greater than 5, I get values as true, right? So if I do like this, print of, if I say print of original numpy which was there, right, and in that if I pass this comparison array, then what will happen? It will give me all the values for which the value is greater than 5, right? So it is, this is how I'll get the value. Or another way I can try is, a shortcut is, take this is the original array, put it in this and say greater than 5, right? So all these 2-3 steps combined in one single step. So it says that give me the elements of this numpy array for which elements is greater than 5, right? This is a powerful feature to have. You cannot do all of this in the list, isn't it? So if I run this, I'll get the value as 678 simply by saying numpy greater than 5. Clear? Can you try it out? So the next thing which we are going to talk about is how we can perform various operations. So let me create a copy of this file. So I will call it 2. Okay, now there are two kinds of operations. One is array operation and another is scalar operation. Okay, so array operation is, suppose if you want to add two arrays, so you can say print of let's say this one plus of this. So it will be addition of individual elements, right? So if I right click and run this program, it is original array, and addition is addition of element by element, you are adding them, right? Similarly, if I try to say minus, it will subtract them, right? If I try to multiply them, it will multiply them, right? If I try to, let's say uh, raise to power, I can say star star. If I say divide, it will divide also. So these are some array operations, right? So this up till here, let's try to run this program and see. So okay, we cannot perform this, just 1 minute. Let me comment this for now, we'll come to this a little while later. Let's first look at this once. Okay, so if I run it, you will see that addition of two arrays, subtraction, multiplication, and raised to power, right? Yeah, so 0 raised to power 0 is 1. Anything raised to power is of 0 is 1. 1 raised to power 1, 2 raised to power 2, 3 raised to power 3, 4 raised to power 4, 5, like this. Right, so this is how we basically perform the array operation with respect to addition, multiplication, division, and all that. Can you try this? Then we look at few other things. Okay, so now coming back to this one which I had earlier on skipped. So in this, what is happening? There is a problem with an operation that I'm trying to perform divide of 0 by 0, right? So what is my original array? This is my original array. So if I divide array by the array, NumPy array by array, it is 0 by 0, right? And that will give a problem which is not a number, NaN. So if I run this program, so for the time being, let me comment all this just to understand what is going on with the last operation. So I'll comment this whole thing up till here, right? So let's try to run it. Now it just says that runtime warning, right? It does not terminate the program, or it does not break the execution of the program, but it simply says that it is not a number. NaN is not a number because we are trying to divide 0 by 0. So this is how basically division works. So these are basically array operation. You can as well do scalar operation. What is a scalar operation? Let me take this, right, and let's say I multiply it plus 3. This is a scalar, so it will add 3 to each one of them. So I will say run as, so it is adding 3 to each element within that array, right? Like this I can divide by 3 or do other operations as well. So what if I go ahead and divide this by 3? So let's see, these are scalar operations, right? So divide by 3, divide by 3, divide by 3, divide by 3. So these are the output I'm going to get. Okay, so that's all we'll do for today. Tomorrow we will look at a rand function, but for that you need to read a little bit about statistics. I'll send a link to you from my website. So this is my page link. I'll share that with you. If you go to blogs here, it's a very simple blog. I mean, you just can quickly read it and understand. One is what is mean, mode, median, and what is a standard deviation. And once we know that, then we look at the remaining 2, 3 more functions remaining in NumPy. Okay, so if you will come down here, you can find about what is normal distribution and what is standard deviation. This is something which we need for the next discussion. So I'll share this link with you. Please go through this. Okay, so that's all for today.